And you don't have to memorize this. If you ever need it, it will be provided, okay? But it shows you how acid strength increases when you're looking at these acids. And you can see up here, our favorite are the really strong ones. They haven't listed all of them. But here you have the perchloric acid, hydrochloric acid, sulfuric acid, nitric acid. And if you have something that's full of hydronium ions, you can say that's a strong acid. It ends up being created that way, but that's okay. They're paired, the ones that are regular ones and not this hydronium ion, with their conjugate bases. Since these are strong, then these are very weak. So you'll see the nitrate ions here, the chloride ion is here. So these are very weak bases. In the middle, you have weak acids paired with weak bases. Okay? Weak goes with weak, but strong goes with very weak. And then here at the bottom, here are some strong bases. They only mention a couple of interesting ones and what they end up. Yeah, well, yes, I would help that OH minus would be a very weak acid, because normally that's indicative that something's basic, right? So yeah, it's about as weak as you can get. So using this now, we're going to list these ions in order of decreasing strength as Brønsted-Lowry bases. Okay, so we're looking at the bases side. And we want to do decreasing strength. This is the side that's strong. So we'll start at the bottom and work our way up. We just have to keep in mind what these are. Maybe we print this out and we start poking and saying, okay, there's the fluorine. I was looking for that earlier, right? Ooh, the chlorine. Ooh, it's way up here. Okay, the OH, that's way down here. But now I got to look for these other weird ones. There's one. Okay, that's before the fluorine. And here's, where is that? NO2 minus. It was here a minute ago. There it is. Ooh, boy, they put those right. Oh, yes. Okay, so once we've identified where all of them are, now we're in a position to write it down. You're just going to follow that chart. And you're going to look, since they said in order of decreasing strength, you'll start at this end and start looking for all of your things. The first one then that we encounter is the OH minus, and I'm going to write that that is stronger than, because since they said decreasing strength, I can keep this in mind by writing that so I don't forget what the heck I was doing. All right, so I can mark that one off my list. I found that one. As I go up here, I'm like, where are they all? Where are they all? Oh, wait, here we go. Here's one. HCOO. Okay. And then that's going to be stronger than, oh, turns out to be the very next one. That was nice. And I didn't have to sit there and start worrying about it. That showed up right away. And then the F minus also shows up right away. And then we have quite a long way to go before we get to the chloride ion, because that's the conjugate base of hydrochloric acid, which is a strong acid. And so this guy he's very weak. So it makes sense that he's last. Very weak because hydrochloric acid was a strong acid. So finding out which one was last out of this list was actually pretty easy. These in the middle, well, heck, you're never going to have those memorized. That's why you need a chart like this for when they start asking questions like that. You're going to have a chart. So next on the same page, guess what? We're going to use our chart again. Now it says list the following anions. Oh, as soon as they said anions, I know I'm going to be using these blue ones again. In order. Why? Why did I know that? Because the anions are formed when it loses the proton, the H+. So, okay, anions. I know I'm going to be using the blue side again. So list the following anions in order of decreasing strength as Brønsted-Lowry bases. So once again, I'm going to start here and go up. So for star 7, okay, I have a nice list here. There's 3 of them again. Oh boy. Okay, this is not on my list. Oh wait, this one is. It's already here. So there's your sulfide ion. Okay. Is going to be stronger than what? Oh, let's go, keep going up for a while. Oh, I found another one. It's right here. Okay. The hypochlorite ion. All right, now we need to keep going again. There we go. There's another one that we were worried about. And time to keep moving along. Where am I? Where am I? Oh, I feel lost. I feel like I'm running out of these. Oh, there it is. Okay. HSO3 minus. And where's the last one?
Brr.
Brr, yeah, brr. Where?
Brr.
I'm going to look one more time, and then I'm like, why isn't it on here? I'm panicking. Okay, don't panic. Stop and think. If I throw an H plus on this, what is it? It's HBr. Oh, that is supposed to be one of the strong acids that I've memorized. Well, if it's a strong acid, then automatically its conjugate base, which is Br minus, is a very weak base. Okay, so it's all right. For the same reason that the chloride ion was very weak and therefore weaker than all of its compatriots, this bromide ion is also very weak. Oh, it would help if I actually wrote the right acid. So because hydrobromic acid is very strong, right? So it's a strong acid. So the same sort of reasoning, but they snuck one in here that wasn't in the list, and we had to use our reasoning to understand that, oh, that's a really strong acid, so it's a very weak conjugate base. Just remember, weak goes with weak. Strong will send you to very weak no matter which way you're going, from acid to base or base to acid. What's the leveling effect? We're going to consider all the strong acids to be equally strong because they completely ionize. Okay, so they're going to form just as many H pluses as each other. We consider all strong bases to be equally strong due to total ionization and formation of OH minus ions. Even though I told you they can form twice as many if they're from group 2. It's like we're just going to call them all the same because of the complete dissociation. Instead of them forming an actual equilibrium, they're essentially going to completion.